Let's look at an example now where we're adding in something hot. Usually it's hot copper rivets, so let's go with that one. Hot copper rivets into a calorimeter, a copper calorimeter that has water in it, and we're trying to figure out what's the final temperature. Okay, so again, here's my problem. I've got, let's do 200 mils, so 200 grams of water at 20 degrees Celsius in a copper calorimeter of mass 100 grams, which is also at 20 degrees Celsius. They're in thermal contact, they're in thermal equilibrium. And into this we will say, let's add 60 grams of copper rivets at 90 degrees Celsius. And we know that specific heat capacity of copper is 390 joules per kilogram per Kelvin. And specific heat capacity of water is 4180 joules per kilogram per Kelvin. Okay, we have our problem. Again, we need to start at a point where we say, well, what's lost heat energy in this experiment if we take this to be an experiment? Well, the copper rivets are at 90 degrees Celsius. They're going to lose heat energy to the cooler thing, to the water, and so on. So what loses heat energy? The copper rivets lose heat energy. Now, what gains heat energy here? And this is a little bit more complex than the last example. Well, the water gains heat energy. And the calorimeter. The calorimeter and the water are in thermal contact. So if we heat up the water, well, that's going to heat the calorimeter. And we're going to assume that the calorimeter is insulated from the surroundings, so that none of the surroundings are going to get heat energy as a result. Right, let's look at how we work this out. Now, anything that loses heat energy is going to be on one side. Anything that gains heat energy is going to be on the other side of the equal sign in our equation. So we're going to have, let's pick a different colour because we already use that. Q for the copper rivets, right? That's the heat energy lost by the copper rivets. It's going to equal the heat energy gained by the water plus the amount of heat energy gained by the calorimeter. It's Q cal for calorimeter. Okay. QC is going to be MC delta theta is equal to, on this side, MC delta theta plus, again, another Q here, so MC delta theta. Okay. What's the mass here? Mass, the copper rivets. C is the specific heat capacity of copper. And delta theta 1 we're going to say here for this. Mass on this side is mass the water. Specific heat capacity of water, because we're looking at the heat energy lost by the water, or gained by the water. And delta theta 2 there, because this is going to have a different temperature change to this one here. Mass of the calorimeter, CAL. Specific heat capacity of copper, because the calorimeter is made out of copper. And delta theta 2 as well, because these are in thermal contact, the water and the calorimeter. So we need to be mindful of that. These are going to change temperature the exact same. They have the same starting temperature, they'll end up with the same final temperature, so they'll have the same change in temperature. Okay. How do we, well, mass of the copper first. Well, we had 60 grams of added copper, so that's 0.06 kilograms. Specific heat capacity copper is 390. Delta theta 1. Now, delta theta 1, we need to think of it like this. Whatever the final temperature is, we're going to call it X. It's like what we did in the last example. We're going to call it capital X. So delta theta 1, the copper rivet started at 90 degrees and reduced down to X degrees Celsius. They fell, the temperature will have fallen for the copper rivets. So how will we find what the change in temperature is? It's 90 minus X. Again, if you're struggling with which way to put this, Imagine that we know what the actual answer is, that the end temperature is 30 degrees Celsius or something. How would you find out what the drop in temperature is? Well, you would say 90 minus 30 is 60 degrees, but we don't know it's 30, we just know it's x, and so it's 90 minus x instead. The mass of the water is, up here it's 200 grams of water, which is 200, it's directly given to us in kilograms, that would be 0.2 kilograms. Specific heat capacity of water is 4180. And now our change in temperature of the water, well, it starts at 20 degrees and goes up to some final value, x. So how would we find what the change in temperature is there? Well, it's x minus 20 then.